Okay, so in the next question, number 6 here, we need to calculate the enthalpy change of the reactions that go from PPO and oxygens that go to Pb3O4. Okay, so first option said that you need to use the enthalpy change of combustions of lead, which is from Pb combined with oxygens that go to PPO. So this is the delta 8 C of Pb. And you can also use the enthalpy change of formations of Pb3O4. So that one goes from Pp plus oxygens that go to Pb3O4 here, and this one will be this delta HF of Pb3O4. So this looks makes sense because it looks like you can form a Hess law here, but there's something you may misunderstand here, because the process that you go from Pp reacts with oxygens to form Pp oxides. Actually, we cannot control precisely the product of this process. So it could either go to the PPO or it could go to the Pb3O4. So we don't know what is the delta 8C combustions of Pp that they are referring to. So the first option is not accurate. There's the second option is the enthalpy chain of combustions of PPO. So that one say the combustions of PPO actually go from PPO combined with oxygens that go to Pb3O4, and that process, this process is the delta 8 combustions of PPO. So right here we already have the results, but they say that you can also use the enthalpy chain for formations of Pb3O4. So you need to use the delta 8C of PPO and the delta 8 formations of Pb3O4. So actually you don't need these if we already know delta 8C of PPO. So B is not accurate as well. So in C, they said that you need to use the enthalpy change of formations of PPO. So that one means you go from PPO, from Pp and oxygens that go to PPO. So this one is the delta HF of PPO, okay? And the enthalpy change of atomizations of oxygens. So that means you go from oxygens to oxygen atom with a half here. Okay, so this one doesn't lead to anything, okay, that relates to Pb3O4. So you can easily see that C is wrong. Okay, so see the last option we have here, enthalpy change of formation of PPO, which is the one we have right here, and enthalpy change of formations of Pb3O4. Okay, so this one now makes sense because see, if I write out what they mean, then what they mean is that enthalpy change of formations of Pb3O4, which is from Pb and oxygens that go to Pb3O4. Okay, so they give you this number. Okay, and we know that if we keep burning PPO, it go to Pb3O4. So now you can see here we form a full Hess cycles here. Okay, so the one results that we are looking for is the delta H will be equal to the delta HF of Pb3O4 minus the delta HF of PPO. Okay, because from here to here it is the direct process, but from here to here to here it is the indirect process. So the correct answer is must be D.